I've been working on a Raspberry Pi Zero build, and that hasn't been going as well as I hoped. But I was going to switch to Melodonic on that one, and then use a little camera here. So the Raspberry Pi Zero, the only thing that does is it does the camera processing and then pushes the data out onto ROS, and then like the Nano or whatever can use that data then. Or it could be a standalone tracker.
Could you show that camera again? Is it just the little Raspberry Pi camera you're using?
Yeah, it's V2.1. I think this is 5 megapixels.
Coincidentally, I got a camera to show off here. So due to the silence,
I was listening close enough. What are you going to do with the camera?
Well, a couple things with the Raspberry Pi Zero is basically I've been trying to read this sensor here. This is a pressure, temperature, humidity barometer sensor. And so, but one thought was to put it onto into a Teensy, just like I2C. But then I was thinking maybe a Raspberry Pi Zero would be better because then it has Wi-Fi and then you can send the data directly into ROS. You already have it into ROS, pull it into ROS, and then it's already published on there. And the camera is just part of that data set. So it's just collecting data from sensors and then publishing that up. And eventually this is trying to go to Farm OS. So we're trying to take this data locally and then stream it up to Farm OS.
So with the use case of TBD later.
Yeah. Yep.
I have to admit, I'm not up to speed on what Farm OS is all about.
It's like an open source farm management tool. So you can keep track of your different areas, stream data, pull out data.
Do you think that camera will be big enough to do weed detection?
That's a really good question. I don't have a good understanding of that. I did talk with, it's called MindsDB, and they're an open source machine learning software. And I asked them about using their setup for detecting weeds versus crops, and talked with their engineers, and they don't have bounding boxes. We would need bounding boxes because we want to turn on a sprayer or know where in our world that weed is. But we're going to try testing out their machine learning libraries and see if it's any better.
Jeff, anything going on in your world you want to comment on?
yes, there is. So speaking of cameras, we just got this camera at work, and Sam's going to use it on her forklift project that she was talking about before. And it's got this big long, like 10-foot cable or something on it, and it's got this little. Let me see if I can switch video here. Okay, so this is what the camera looks like. It's got a focal length of like 3 to 8 centimeters, I think is what it is. And it's got this thing on the cable here, this little adjustment, so you can turn the knob. I don't know if this will show up. I guess I have to keep talking here so my video stays on. You can see the brightness change in the background. So it's actually changing the. You can change the illumination. You can turn it off completely if you want to. And I just posted a link to it, and these are $10.
Wow.
Good grief.
and it just, you plug it in, it shows up just like a regular USB camera. So whatever you can do with a regular USB camera. So if you point it quite a ways away, see it's out of focus, but still that's 10 or 15 feet away, and you can tell that those are boxes sitting on the table there. So that's something interesting that's popped up. So I'll have to get me one or two of those to play with. And you're talking about looking for weeds or whatever. It might work for that. Depending what you're looking at. I was thinking I could put one on the front, just have it looking down and do like line following. So if there's a line on the parking lot, you use it to follow that. But just so small, and I think they even say it's waterproof. They either say it's IP67 or IP68. So if you wanted to, you can shove this down your drain to see where your drain's plugged up. So that's something to consider. So,
do you have a link for that, Jeff, that you can post?
What's that?
Do you have a link for that you can post?
Yeah, I already posted that.
Oh, okay.
It's just a search on eBay and it'll show up a bunch of them. They seem to be around $10, and some people sell it for $5 with $5 shipping or $10 with free shipping. And the side of the box says it's got all these options, and this says 5 megapixel and soft wire. So I assume the hard wire is just a stiffer cable on the thing, and where it says 5.5 and 7 and 8 millimeters. I don't know if that's the focal length or what that is, but anyway, it says it's on the side of the box. When I was looking through the eBay ads, it looks like they're selling all the same one. I don't think you get to choose which one you want, but if you're really concerned, you could go down the line and find, see if you can find different options when you buy it. So what was the next thing? Any more on that camera?
Is there a driver for using it in a Linux, i.e. a Raspberry Pi platform?
Well, it just shows up as a web camera, and if you plug it into Linux, it shows up as /video/dev/video0 or something, and it just shows up as whatever you normally use your web camera for.
Cool.
So since I got the camera here, and this is my, see, you can get real close to stuff, and it does a really good job of, that's even right side up. So there's the,
that's amazing.
There's the SparkFun Razor IMU board. I'll show that a little more of that in a moment. And here's the Tindy boards. One of them is the MPU 9250, and the other one's that whatever the one is that Matt's got and Walter just ordered. And so I'm going to try to wire one of those up and probably start with Matt's code that runs on a Raspberry Pi. And there is a Fidgets 3.3. Al, could you mute your audio so it quit switching? So there's the Fidgets, and somebody 3D printed a case for it. So it's got just a little board that's inside that plastic case. And here's that UM7 from Pololu, and it's got its own, it comes with a case. And then I put a USB to TTL adapter on it. So those are the ones I want to try bolting on a board with a Raspberry Pi to make my IMU farm that I'm going to build. So let's see. Let me see if I can switch my camera back and share my screen. Screen 2. Why didn't that work? There we go. I assume you can see my screen now. That's the this is one of the SparkFun boards with their software loaded on it, not the one for the ROS driver. And it's I think it's going to be nice because this one lets you test a lot of stuff. So right now that what's showing up is the time. So if I hit the T key, got to get focus. Hit the T key, that goes away. So you can say turn on the time. You can say turn on the accelerometers, turn on the gyroscopes, or the magnetometers, turn on the Euler angles, turn on the quaternion, and then there's one called heading. So you can turn those on and off and get whatever you want to come out. And then you got one more option here, which if you look at these first few columns here, it's coming out as 0.17 something. If I hit the C, that changes it to A to D counts. So you got raw data versus calculated values coming out of it. So this is going to be a handy way to take this board and lay it on the table and see what kind of values you're getting and rotate it around and see what's coming out. And then number one, see if the values they're giving me matches what I expect it to be. And then if I'm happy with all that, then I can move to the software that comes with the ROS driver, which is somebody else's software that does various things. And then I can compare against that, because that thing that Matt Sadowski posted where he says he's got that PixHawk autopilot, and then he put his Razor IMU on top of that and he rotates them. The PixHawk just works perfectly, and then the Razor one did not. So that's a good reference against that. And then he said he loaded he's got that other one he posted, that Fidgets, where he's got the Fidgets IMU, and that one is that one seems to be working great too. So this is a way to compare back and forth. So I can go back to the Razor and say, now why is this not working? It's doing something. It's obviously doing something stupid. So now maybe I can figure out, track down the different things that it's doing and figure out what's happening there. So I guess let's see, I stopped sharing, didn't I? Let me put my sharing back up. And then open one of these. So I was saying before that I was plotting out my GPS files. Well, this one I went ahead and took the moving baseline heading and pulled that out to extract it. So the orange one on here is the moving baseline. I can tell because it's screwed up right here. So that's how you can tell when looking at the different colors here. Whenever it's screwed up there, that's the moving baseline, and the blue one is coming out of the hemisphere. Hence the title up here, F9 moving baseline versus V200 heading. And just, without zooming in, they're both holding the heading like they're supposed to. And over here somewhere, here's where I back up. This is the other, this is the computed heading down here. And when I back up, that flips. But whether you're using the V200 heading output or the F9P moving baseline, the heading does not flip on you. So even though I was backing up at this point, it stays where it's supposed to. And then this plot is simply all three of those put together. So the blue is the computed heading, the computed course over ground out of the F9P, and it looks like the gray one in this case is the moving baseline of the F9P, and the orange is the hemisphere heading. And if you look down here, this is when my thing came to a stop, and it stopped because, first of all, it stopped because I noticed I wasn't getting correction data, so I stopped and was running around. So this whole time you can see the speed down here is 0. And while I was doing this, it was coming along, and then all of a sudden it started drifting off and doing stupid things. I thought, well, how can I detect that? See, do I have this? Just a zoomed in of that same thing again. So I thought, well, how do we detect that? So I was looking around, and I found on the same message that puts out the moving baseline also puts out the baseline length. That tells me the distance between my two antennas. So if you look right here, if I can get this to show up on Excel. Anyway, it says that line is 75, which says, or 76, there it is. I measured the two antennas are 75 centimeters apart. So as long as this line should be a straight line all the way across here, because the distance between your antennas should never change. But you notice out here where it's screwed up, you can see that the distance between them starts changing. And I was thinking, well, maybe you could use that. So you put a threshold on that, say if it's off by some amount, just ignore the thing. So that might be one way to do it. And then down here are flags that the thing is putting out. So while it's running, one flag says you've got a moving baseline float or moving baseline fix, or is moving baseline active. So there's like four or five different combinations that are added together here. And you can see where it screws up really bad. Well, actually, yeah, when it screws up really bad, there's a lot of chatter on these flags bouncing back and forth down here. And the whole reason it seemed to do this is because if we go back, let's how to get the other one. Because when I came along, everything was working fine. I came to a stop, and then I was sitting there for a while. So I actually lost the reason I stopped is because I lost correction data. And I didn't think that the external correction data was supposed to affect the moving baseline heading, which is computed between the two devices, but apparently it did. So I don't know why it did that. So that's more stuff to look at. But considering I only have two reference log files at this point. This is the one that had the hemisphere on it, and the previous one I ran it was just the U-block stuff. So now I know what to look at. So hopefully I can make up log files that will have the data I want or know what to look for in those. So that's kind of where I'm at with that. And other than that, I can't think if I'm doing anything else. So I'll turn it back over.
Well, that's a lot. It's cool to have all of that that comparison data.
And when I was looking at the IMU stuff, I realized, yeah, there's, you know, like just multiple versions of all this stuff out there. So now I got to go back and start from scratch and figure out which ones are appropriate and which ones are not. It turns out the Razor IMU, I was looking at it, and they haven't changed the code in 3 years on that. So probably what's on here is what I loaded 2 years ago when I started playing with it. They made one change to it. There's something about when you do calibration, you have to turn on an extra flag in the MPU 9250 flags for the built-in motion processor. They added one line of code that turns on, sets another bit in the flag bits. So I'll probably recompile that and try that before I get too carried away with it. Because it could be the magnetic calibration has never been correct on this because of that, which they just did 9 months ago. They added that to it. So definitely that isn't in what I have right now. And then I go look at the stuff for the ROS-based one, where they give you a ROS node and then they give you somebody else's Arduino code to load into the thing, and that's different code. And that there's hundreds of versions of that out there, so I have to track those down and figure out if any of those look like they're right. And as Matt Sadowski pointed out, his friend has posted some code, and he added some stuff to it. So I'll probably start there with it when I get that far. So I can now compare the output of the Raspberry or the SparkFun output to the ROS version output. And as I move the thing around, it should act the same. So it's the angle should be the same, the rotational rate should be the same, and the magnetometer should be the same. So that's just somewhere to start on that.
At the moment, if I mean, you were just to pass somebody on the street and say, what's the leading horse in the race? Would it be the fidgets?
That just seems to be people's opinions, and I can't find anywhere where somebody says I sat down with all these different devices and tried them, and this one works the best, this one works the worst, and kind of out in the middle here is some other ones that might work. So I don't know. And then there's that other one that I know Kyler kept saying, "Oh, try this one, some block or something," and I've never tried that one, so I don't know anything about that one. So
Yeah, it's German.
There's lots of devices out there, and it just seems to be opinions on everybody's part whether or not they work and how well they work.
Yeah, the one you're referring to is a brick IMU V2. I think if you're Googling, that's what would get you to it. Comes out of Germany, I believe. I have one. Hell, I might have two. But again, I wasn't ever pleased with it from a heading perspective.
And then back to my comment about it just comes down to people's opinions, and then some people aren't quite as critical of it. So somebody grabs and says, "Yeah, it's telling me an angle. That's close enough for me." And so you don't know if that's as good as reference as somebody that says, "No, I spent 6 months trying to figure out how to get it exactly right." So that's another thing that gets thrown into the mix, trying to figure it out. And as you point out, you buy this thing and hook it up, it doesn't work as well as you expect, and that's kind of where I'm at with most of my stuff, trying to figure out what do you do with it. But that stuff that Matt Sadowski posted with his fidgets, that looks like it's working really well. And our first project that we did, that's what we had on it, and that's why I have one laying here, because that's what we ended up going with. We tried 2 or 3, and we couldn't get any of them to work. And then Rod says, "Well, back in college we used this one," so we bought that. We put it on, and it seemed to be working, and so that's what we went with for our project. And then, of course, in the follow-on, then of course, being Danfoss, we have to have cans. They've been buying ones that have CAN interfaces that we're going to try to get those to work, and we need some way to compare those, or it'd be good to have somebody to compare those to anything else that we have to see how all this stuff works. And so far, I haven't found anybody that sat down and says, "Here's a comparison of all the IMUs I could find," and it'd be nice if somebody would do that.
And you mentioned
maybe Matt wants to do that.
Matt Sadowski.
No, you. No, maybe you want to do that.
You mentioned USB to TTL. I've been mucking around with serial TTL USB. Actually, no. One more time. What are you using the TTL thing for?
Oh, this UM7 board just puts out a serial. It's serial in and serial out. So to get it to USB, I just got a little TTL to USB converter on it.
Do you happen to be using that Max 3232 chip? in that?
It's just some random, I don't know what's on it.
Yeah, I don't. I mean, I
No,
accessible
because
computer.
the Max 232, that's actual serial. So you're trying to go to real serial, or are you trying to get to USB? This converts a TTL to USB. And then I've got some of those other ones like you're talking about laying around that I've used for various things.
Yeah, my correction data comes off of my GPS development board, and I've got a TTL serial to TTL converter to get it down to 5 volts, and then I'm feeding that into ultimately my 3DR radio to go into another 3DR radio, which will have TTL to serial on that. So, I think that's a not by preference. That's simply because my GPS boards talk serial.
When you get done playing with that, I think you got to go back to your Ethernet and see if you can figure out how to do it that way. Did you say you wrote to them? They sent you documentation on the Ethernet, so you know what that will do and how to set that up?
I did. I haven't spent any time on it yet, and so I'm not exactly sure if all the command set is going to be there or not. It seems to be focused on being able to configure the GPS via Ethernet, as opposed to get correction data out. The correction data seems to only want to come out in a binary format. So I'm like, how am I going to do this? So I just haven't wrapped my head around yet. My correction data is coming out in binary. How do I get that into an Ethernet thing?
Is that a document they sent you on the Ethernet for the thing? If so, can you forward that on? So either at least to me, or I don't know if we should put it on the group or not.
Sure, I can share it with you. Yeah, that's no problem. I'm sitting in my truck and not in front of my computer, but I'll send it in a second.
I'm no hurry for it, but it just seems like I know on the stuff we've played with, both the Swift Nav and the Novatel, I was able to just use the Ethernet port. And on the Swift Nav, I can say set up a server on the Swift Nav for Ethernet, and then have the other one connect directly to it. And then I can also go in over Ethernet and run the ROS driver over that, and at the same time you can also log in over Ethernet and do configuration or whatever you want. So if you can get the Ethernet to work, that works out really well, because that takes care of all that. And I think you can just take your receiver and plug it right into the switch on your router, and then that will give you a connection between those two. And then at the other end, if the Raspberry Pi is the one that's talking Wi-Fi, then coming off the Ethernet port on that, you should be able to plug in your other receiver to get the correction data across. The only trick there is going to be you're going to have to figure out how to create a bridge between the Wi-Fi on the Raspberry Pi and the Ethernet port, or it could be you got that trick where you can go in and say share this to other computers. That might be enough to make that work. So anyway, if I could look at that and see what kind of stuff they're sending out and how they're setting it up, maybe I can have some suggestions on that.
Yeah, that'd be fantastic. I mean, because it would be wonderful to be able to do it all with IP. I am still fighting. I don't know if earlier. I'm still trying to figure out my. I can physically wire my 2 GPS boards together. Correction data over a serial connection. I haven't been able to convert that to radio link. So I'm still struggling with that. I think I've got a solution, but there yet. That'll be my weekend work. I have looks like I have a little bit of way to do some work on it on the weekend. Matt, anything else going on in your world?
Getting ready to go to the Small Farm Tech Expo.
Oh, that's cool. Where's that at?
It's in California, Santa Rosa.
What are you hoping to see there? What vendors do you think will be displaying stuff?
I'm curious, yeah, to see. So this is kind of geared towards small farms. So I'm kind of curious to see what technology they're using and what technology they're interested in.
You going to do a FaceTime live from there? We'll all join.
Jiminy Christmas. I don't know. Maybe.
I mean, show us, what the boots you've got on and the grass you're walking through. It'd be cool.
All right. There are some field demos, but a lot of this technology is low tech. But it's kind of cool to see, small. So think small farms, like vegetable farms, 1 acre, 3 acres.
Yeah, I'm looking for that 1-row seeder and that
Yeah.
small hay baler, and yeah, that'd be cool. I promise you, as long as the hour is social, I will join your FaceTime live.
Okay. FaceTime Live. I don't know about FaceTime Live, but I'll send you some.
We'll do a Slack thing or do a Zoom thing.
Okay. It's Monday. It starts Sunday night, and then Monday is the workshops. But I'm not sure what time the field demos are.
Yeah, just let me know. I'll put it in my. I'll carve time out of my day.
Okay.
And it's in Northern California. Is that what you said?
Yes, Santa Rosa. It's supposed to be the #1 farm school in America. Like they teach you how to farm. This is like a educational farm where they expose that.
Dude, if they have cows and they're making compost, you have got to let me know. Seriously, I will. Get up early, stay up late. I want to make compost with cow manure.
Okay.
Save the planet. Sequester carbon.
Smart.
Yeah, my phone is freaking out here. It's getting too hot.
I failed on my camera with this ESP32. I failed on that experiment. I got the wrong chipset. So if you're wondering, on the back of these boards, it will say AI Tinker, and or AI Thinker, and that's the one that you want. These are kind of knockoff boards off of eBay, and I never got it working. So report on that. $10 camera, IoT device.
The other thing I'll just share that I've been spending time on is for my base station, because I don't have a public source for correction data. I'm intending to put a base station in the yard/field. I've been educating myself on batteries and how to put a small solar panel and inverter and battery out there to drive the Wi-Fi and correction data. So that's been fun and interesting. So I have a 12-volt lithium battery that I bought from AliExpress, and I've got some stuff on the way to try to get that all hooked up. Yet more learning to do.
Are you going to put that on solar panel, or what was the power?
That's what I was thinking is I would have, to start with, probably just have an extension cord running out into the yard. But yes, put a solar panel on that. So it's effectively, I don't have to schlep it in and out all the time, just leave it out there.
Yep.
But there's just a ton of stuff on lithium batteries. I mean, holy cow. That's really an interesting technology that seems to be, the power density on batteries really seems to be coming a long way. So we'll be doing like Jeff and having an electric vehicle instead of a gas-powered vehicle.
Exactly.
Other than that,
on RTK Corrections, there does look to be one in Pennsylvania, but it's a ways away from you. But having your own base station, that's the best way, most reliable.
Yeah, I'm not too fussed
More
about it.
accurate.
If I can get my daggone radio working, I think it'll be fine.
Yep.
Because the geography here is very hilly, and in Texas it's remote, so I think having a local base station, for me anyway, is the right thing to do. Jeff, anything else you want to comment on?
Speaking of correction data, I haven't heard back from that guy. I think he was in Washington that was trying to get his F9P to talk. He said they were bolting on the device. He didn't have access to it for a while, but I haven't heard back if they've got that working or not. And the guy in California that was building the last mile delivery vehicle, they said, "Oh, we got it figured out." He was complaining that the dev kits, something about they've come with some kind of a built-in radio. So instead of having like that 3DR radio, it's got a chip built onto the board. And he was claiming that when you get these things, they're programmed one of two ways, and they don't tell you which way it is. He says the documentation doesn't tell you anything. So they fought with that for quite a while, and they finally got it. They had it at the point where by just connecting the two boards, and they're using the actual U-Blocks boards, there was C099 boards as opposed to the RGU simple boards. And it turns out if you take those two boards and connect them to two laptops or run that use center software they give you, they could make that work. And then they could connect, I think he connected a wire between the two and got that to work. And then he was trying to get it to take out the use center software and just get it to run on its own. He couldn't make that work. And he found several references. And finally, I think he got it to the point where he connected the two boards together with two wires and then was able to get it to talk. So I think he's bypassing his radios completely now, which considering the boards are going to be, 3 inches apart or something, he doesn't really need the radios on there. So so last I heard, I think they're fairly happy with what they've got running now, because he wanted to get the moving baseline on their little vehicle. And somebody asked what's it made out of, and I went back and looked at it. It turns out it's one of the Segway robots that they've got that, and then they added like some caster wheels onto it to make it into like a 4-wheel vehicle. So that's what the vehicle actually consists of. And then originally they had the Swift Nav receiver on there, and now they're switching over to the U-Blocks receivers. And he's got one of those little 3D lidars like I was demoing one time, and I asked him, how well does it work? He says, well, we just got it bolted on. We haven't looked at it yet. So they're kind of the same point where I was. They're just playing with it and don't have it actually running yet. So it'll be interesting to see how they come along on that. I guess that's the only other person I know that has one of those. And so we'll see if he gets it to do anything. I guess that's all I got at the moment. So.
So Matt, when are you leaving for your Northern California thing?
About 15 minutes.
You keep taking your track?
No, but I wish I found out about this late. That would have been cool. Yes.
You can still take it to the parking lot and just have a tailgate thing.
Yeah.
Okay, guys. Well, seriously, I am going to be pissed if I found out they have cows and manure and compost, and you don't slack me, man.
Okay, I haven't seen any cows, mainly vegetables, but maybe when we get there, we'll see what they have.
Well, even if they're goats or lambs, anything pooping and composting, that's what I want to see.
Okay.
We'll see you guys later.
All right.
And Jeff, I owe you the Ethernet manual that ComNav sent me.
Okay.
We'll see you guys.
Okay. Goodbye.